Okay, so today we're going to deal with a binomial distribution. And here's what we're going to do with a binomial distribution. We're going to just figure out the probabilities of different events that have success and that have failure. So let's say I'm going to shoot 3 free throws, and I want to make 2 of them. And let's say I'm a 75% free throw shooter. So when I'm thinking about this, what I would like to do is I would like to figure out that probability. And when we do this, I always like to think of my events and go, I need to make 2 of the shots, or I need to have 0.75 and then 0.75, and then I need to miss one of my shots, which missing would be 25%, and then I need to think of all the different ways that that could happen. So if you think back to yesterday, the order of these things don't matter, and we want to think about all the ways that we want to do this, so that we have 3 different things total, and we want 2 things to happen. So we want to have 3 shots, but choose 2 of them that work, or that we make, and that would be all the different probabilities that you could get. We could also write this a little bit of a nicer way. Like this could be really written as 0.75 to the second power and 0.25 to the first. And normally this is how these things are written, just because it's easier to enter in. Let's enter this in the calculator and see what we get. So we'll have a combination of 3, choose 2, times 0.75 to the second times 0.25. And our probability to make 2 out of the 3 shots would be 42%. Let's try this with a different word problem and kind of go through it with some more complicated examples. Okay, so here we go with example 2. So it says a pharmaceutical lab states that a drug causes negative side effects in 3 out of 100 people. To confirm this affirmation, another lab chooses 5 people at random who's consumed the drug. What is the probability of the following events? None of the 5 people experience side effects. So we know 3 out of the people generally will experience side effects. So we know the percent chance that they do this would be 3 out of 100, or 3%, which means the percent chance that they don't experience side effects would be 97%. Now when we're looking at this, we want no one to experience side effects, so we're going to say 0 people are going to get this, but we're going to say that 5 people are going to have no side effects. So this is the percent chance that 5 people would have none, and then we need to do our choose. So 5, choose 0. If you ever think about what a choose 0 would be, that'd be 1. Like there's only one way to get 5 people to not have this. And so then we'll put that in our calculator, which would really just be this, because anything to the 0 power is 1, so it goes away. So 77% chance that no one experiences side effects. Let's figure out the percent chance that at least 2 people experience side effects. Well, so we would want 2 people to experience side effects. So that'd be 0.03, and we want 2 people to have that done, where we want 3 people to be okay out of the 5. So this one we'd have to type in our calculator and see what we get. So that would be math probability. 5, choose 2 times 0.03 to the second times 0.97 to the third. And that looks to be around 1%. A little bit less than 1%, but close to there. So okay, now we need, I guess that would be at least 2. Whoops. So that would be just 2. Then what we would have to do after we do just 2 is, if it's at least 2, we'd have to do this for 3. We'd have to do this for 4. And we'd have to do this for 5. So this will take a little bit. And you can kind of see the pattern. I think this is the last one we're going to answer because it's going to take us a little bit. But you can see the pattern of how this kind of works. Like every time I increase one, the other one goes down. So, whoops. And then this would be 0.97. I guess I don't really have to write that because that's the 0 power. And then we'll figure out what these percentages are and then kind of go from there. So let's do second entry, and then we'll just change this. We need that to be now 3 times, this to be 3 times, and this to be 2 times. So that's even smaller, so that's less than 1%. Let's see. Whoops. That was a mistake. That's even smaller. So we can see that this is probably not even going to equal a full percentage if you add all those up. So it's going to be 1%, like you would add all those things. But if you're adding numbers that are so small that they're not even percents, a lot of times you just go, well, that's going to be around 1%, and you're going to be happy with it. Okay. Fewer than 3 people. Fewer than 3 people should work kind of the same way when you think about it. What you would do is you'd say, we have 5, choose 3, and then we'd have to go to 2, and then we'd have to go to like 5, choose 2, 5, choose 1, 5, choose 0. We already did, so we could go through that. And then what is the average number of patients that a laboratory should expect to experience side effects if they choose random 100 people? Which you could say, well, the expected number of people that would have these side effects would be 100 times 0.03, and that would be 3 people. So, which makes sense because 3 out of every 100 patients experience side effects. So if they had 100 people, they should expect 3. But when you're doing any of these problems, if you get stuck, let me know. The hardest part about it is some of this is time consuming sometimes when you look at this, because you can see in this example right here that we have to add up a lot of things, so it takes a while, but that's the main idea. You do the number of combination odds here, you put the percent chance of success, percent chance of failure, multiply all that together, and see what your percent is. Try the different problems. If you get stuck, just let me know.